Next part in the pre-training of BERT is next sequence prediction. So as I told you earlier, in pre-training we would be training the model on two major problems, that is MLM, masked language modeling, and second is next sequence prediction. So let's understand what is next sequence prediction. So assume that we have three sentences. He is handsome, the sun rises in the east, and his name is Raman. Now, if we form two input sequences using the above sentences, he is handsome, his name is Raman, the sun rises in the east, his name is Raman. Now, in case of next sequence prediction, what we're trying to check is whether the second sentence in a particular input is associated with the first sentence or not. So, in case of first one, he is handsome, his name is Raman. This is associated. In this case, the second sentence is associated with the first one, but in case of the second sentence in case of the second input, the second sentence is not associated with the first sentence. So for the first one, the label would be yes. Yes, the second sentence is associated with the first one, but in case of the second input, the label would be no. So in case of next sequence prediction, what we are doing actually is that we are trying to figure out we're trying to make the model understand, in case of multiple sentences coming in the input, whether the second sentence is associated with the first one or not, or vice versa. Now, how to prepare the training data set for next sequence prediction? So it's pretty easy. We would pick out a particular document, any document we can pick out. Now we would be placing two consecutive sentences together from the document and label them as yes, and then pick up two random sentences from the same from the same document or from other documents as you wish, and then label them as random, label them as a zero. So join two consecutive sentences from either document and mark as yes. Take two random sentences each from two documents and mark as no. So this can be like, I guess you must have got an idea how we are trying to prepare the training data set. If you're able to pick out two consecutive sentences from any random document, the label would be one. Else, and then we would be picking out random sentences from different documents or even from the same document. And the same document can be an issue. So because we might find some association, so it would be better to take sentences from different documents and mark them as no. Now, the embedding that we're generating is pretty easy. It's pretty similar to what we discussed in MLM. Also, we would be adding the CLS and STEP tokens as we discussed in case of MLM. Now, let's understand the architecture, how it is changing a bit. So, again, assume that we are inputting the sentence, she cooked pasta. It was delicious. Now, it again goes to the BERT base model that comprises of 12 code blocks. After that, once we get the attention vector for each of the input token, we would be taking the embedding for the first token, that is CLS token, and we'll be applying a softmax plus feed forward network to get for the binary classification whether the second sentence was no next or is next. So as you can see that the probability for is next is 0.9, hence she cooked pasta, it was delicious. So it was delicious was associated with the first sentence. So if you remember, in case of MLM, what we were doing is that we were applying the softmax plus feed forward network on the masked tokens embedding. Now in case of NSP, we are applying this softmax plus feed forward to the first token, that is the CLS token. So it's the CLS token that is helping us to determine whether uh, the sentence that the second sentence in the input is associated with the first sentence or not.